Hello and welcome to the session. My name is Trevor Bloch and I'm the CTO of VROC. So during the session, I'm going to give you a bit of an introduction to what VROC is, who we are, what we do, what some of our product offerings are. And I'm going to use that to relate how we use IoTDB to fulfill some of the requirements that our solution has. After that, I'll go through some applications of our software in various industries and some customer success stories, which is always important because that's why we do this. Why are we using IoTDB? Why does VROC exist at all? It's obviously to provide some value to our customers. And so really identifying what that is helps us realize why this is so important to get this right, why it's so important to be able to gather and process this data to provide these insights to our end customers. But first, let's go through an introduction of what VROC actually is. And so VROC has been around about 10 years, and we really formed to solve a specific problem. And that was that if you look at the amount of data that's produced in industry, through all of the IoT sensors, through all of the control and automation systems, through all the safety systems, for all the monitoring and manual entry data that's being generated, about 44% of that data goes completely uncaptured. So we have sensors generating data from us day in, day out. 44% of that data is not being captured or historized at all. So out of the 56% of data that is captured and stored, only about 57% of that is actually used for any purpose at all. The other 43% of that data is not even used. So they capture the data, but it's not used. And so overall, we see that 68% of data that is generated goes completely unleveraged. So they don't use it for anything at all. And that's the whole point of VROC. VROC is there to be able to gather all of this data and make sense of it and provide meaningful insights to our end customers. And so we do that by trying to provide a very fast deployment for our solution, which results in a quicker ROI, return on investment. So we try to eliminate this high upfront cost and this big effort that's required to set these sort of solutions up by having a very fast and quick deployment. We have a very scalable and flexible solution. So you can start with a very, very small system. You can scale it as required. As your requirements grow, and flexibility to do different things. So we're not limited to just one type of analytics. We do a various analytics across all of the data that our customers generate. And we're cost effective. So as I mentioned, we don't want to have to initiate a very, very large project to get this sort of solution up and running. We want to be able to do this as a very, very staged, small implementation to do a POC and then scale it up as required. And when we say cost effective, we don't just mean cost effective in that the solution doesn't cost a lot to deploy or to manage. It's also cost effective in the form of resources. So we try to ensure that the solution requires the minimum amount of resources in terms of data storage, in terms of network capacity, in terms of CPU processing, because obviously all those things are important factors when we're looking at solutions in this space. And then when we look at the different industries that VROC works in, we work on the process industries, oil and gas, mining, and primary industries. We work in discrete industries, renewables, utilities, and maritime. And we work in smart cities or smart facilities, which is building management, city councils, local government, as well as campuses like university or business campuses. And throughout all of these different industries or asset operators and maintainers, there's a few key analytical outcomes that we want to achieve. We want to ensure that they get predictive maintenance and time to failure. So that is, we want to be able to quantify the amount of time before the next undesirable event occurs. And we want to give them a heads up before that happens so that they can take the appropriate action to prevent the undesirable event in the first place. We want to be able to optimize their process. So by looking at the data that they generated, we want to make sure that their process is optimized in respect to using the least amount of resources, producing the most product at the highest quality. And for some customers, we just want to do performance and remote monitoring. So for some customers, they've got geographically dispersed assets that might be located all over the country or all over the world, and they want to be able to monitor them from a single location and to optimize and control them from one place. Digital twins are another factor that another service that we provide. Obviously, digital twin is just a digital representation of a physical asset. And so by using AI machine learning and some of the features of IoTDB, we're able to achieve that. And finally, we do control systems. We allow our users to control their facilities. So, they might be able to remotely monitor them and identify how they're performing. They might be able to do some analytics to try and optimize them or identify what's about to fail. We allow them to control them as well, to make physical control changes to the equipment remotely. And if we look at just an example of an oil and gas operation, we can see what a big difference this sort of technology actually makes on the ground to these operators. And I think if we look at the graph on the right-hand side of this slide, we can see that at the beginning of the graph, the line is very, very high and it's very, very unstable. And that line is showing the production losses from these oil and gas platforms. And production losses occur whenever there's an unplanned or unexpected failure of equipment or process, which means that they can no longer extract oil or gas at the normal rate. And so that graph is data that we've received from our end customer that shows how much the production losses have been prior to VROC being installed on their facility. And we can see that those production losses vary month by month, but they're always above zero and always reasonably significant for this particular operator. On the right-hand side of that graph, we can see in the shaded area is where the VROC live monitoring started. And you can see that from very, very early on, those production losses dropped to zero. And in some cases, they actually went negative because VROC was able to optimize their facility and produce more oil than they were expecting under the current operating conditions. So significant change in production losses and significant advantage to this customer. So they estimated about an 80% reduction in production losses year on year from not using this technology to using the VROC technology. So the savings are significant and are very, very clear when you see what our end customers are able to achieve. Now I'm going to go quickly through our product offerings, and then we'll go through and see how that relates to IoTDB. Okay, so VROC really has four main product offerings, and I'll just briefly go through each one. So we have Discover IoT. Discover IoT is our low-cost, self-serve, very, very easy to use IoT data acquisition system and AI analytics system. So this is for clients that don't have any existing data collection or sensors on their facilities, and they are for very basic assets. So you might have a pump, you might have a compressor, you might have a turbine generator, really, really basic bits of equipment where you can really quickly start monitoring them and getting AI analytical insights in a very short period of time. We have Data Hub, which is our data historian and visualization platform. So more for performance monitoring, but a lot of our other products are visualized through that platform. We have Opus, which is our self-service no-code AI. So it allows you to build AI models and find insights without having to know anything about data science or AI. You just have to know about the problem that you want to solve. And we have Oasis, which is our remote monitoring and control system. So now let's look at how VROC is using IoTDB in our software stack. So the IoTDB use cases that VROC are using it for is obviously time series data storage. Now this is obviously what IoTDB is renowned for. So storing historical data and storing real-time sensor data as it comes into the platform. VROC uses IoTDB for feeding some of our front-end applications. So obviously front-end applications are very time sensitive. We need data to appear very, very quickly. We don't want to have any lag for our users. So IoTDB is used to source that or to serve that time series data for the front end. We have data for AI model training. So AI model training obviously needs large amounts of data for AI models to be built. The good thing about these AI model training is that obviously We don't need this to be in real time. This can be done offline. This can take, half an hour or a couple of hours to train. So there's a much lower load on the system, but obviously we need a lot more data than the front end requires. And we use it for AI model inference. So once the AI models are built and once new data comes into the system, we can use IoTDB to pull data to be able to infer new insights from all of our trained models. So those are the main use cases that we're using IoTDB for. And I guess, the big question is, why are we using IoTDB versus other solutions? And obviously, we've been around for 10 years or more than 10 years. We've used lots and lots of different time series databases, from standalone databases to large clustered databases. And one of the main reasons that we use IoTDB is the simplicity of operation. So for IoTDB, there's only two processes required. You only require config nodes and data nodes. And obviously, I'm talking about a clustered deployment here. But a lot of the other databases that we used to use Apache Druid before this, need a lot of different processes that all need to be configured and running and optimized separately to ensure that the whole system's running. With IoTDB, it's very simple. Config nodes and data nodes is all we need. The next one is a small number of processes. So as I mentioned, the most basic installation for IoTDB for us in a clustered environment is 3 config nodes and 5 data nodes. And with that, you have a relatively powerful time series database system. When we compare that to Apache Druid, you need a router, you need coordinators, you need overlords, you need historicals, both hot and cold. We had hot and cold historicals, and you need brokers. You need lots of different processes that all need to be optimized and configured separately. They all need to be running for the solution to be working, and they all use quite significant resources. So if we look at the next reason that we're using IoTDB, is the low resource utilization. So as I mentioned, using Druid, we need significant resources for all these processes to run the solution. For IoTDB, it's a very much lighter system. So we generally use 3 gig of RAM for a config node and maybe up to 24 gig of RAM for a data node, depending on the load. But overall, you can have a really high performant time series database system running in the cluster for under 120 gigabytes of RAM. If you're looking at the comparable solution in Apache Druid, we were using over 750 gigabytes of RAM to handle similar workloads, and they had significantly more CPU requirements. So these are the main reasons we like it: simple operation, very small number of processes, and low resource utilization. And when we look at the type of the data storage characteristics of our data, so we have large data volumes, obviously coming in real time from lots of IoT devices and other sensors from our industrial assets and facilities. Most of that data comes in reasonably regularly. So most sensors are sampled at a regular basis, 2 seconds, 1 second, 10 seconds, 1 minute. The data comes in quite frequently and quite predictably. We do have occasional peaks, so perhaps you might have started a plant or shut down a plant. Obviously, the data characteristics will change, but generally, for most of our deployments, we have up to 500,000 samples a second as a typical ingestion rate. Obviously, we have various data volumes for various environments, for different environments, but that's kind of a pretty good average. In our solution, we use Spark streaming jobs to handle data ingestion. And obviously, we need data for AI model training, and we need data for AI model inferences, which I mentioned previously. For our deployment of IoTDB, our whole solution is containerized. So we deploy our solution through any container orchestration platform, be it Google Cloud or Kubernetes or Docker, Swarm, or whatever the case may be. We have a containerized cluster deployment. So for IoTDB, VROC has a customized container that contains all of our specialist and I guess not proprietary, but custom IoTDB deployment and configuration options. So we have one container for data node and one container for config node that we deploy in our cluster. These are typically deployed within a Kubernetes environment, which is what our private data centers run. They run Kubernetes. And we use Helm or Helm scripts to facilitate rapid deployment and upgrade. So Helm just allows us to have a very repeatable and rapid deployment of the solution, but it also allows us to really easily handle upgrading and migrations across a large install base. We use Kubernetes because it has automatic load balancing. So as we spin up more pods or more processes in the Kubernetes cluster, they're automatically spun out to nodes that have available resources. If a node or some hardware fails, those processes are automatically shifted onto another node. So it's very resilient, and the redundancy is fantastic on our Kubernetes cluster. One thing that is difficult, I guess, for this with this architecture is that by using the Helm script, it makes it very difficult to scale out the IoTDB instances. So if we want to go from 5 data nodes to 10 data nodes, that's going to be a manual operation. We're going to have to manually run the commands to do that. If we move to more of an operator pattern in Kubernetes, that would be handled more automatically. But as I said, at the moment, three config nodes and 5 data nodes is extremely performant. And so the requirement to scale out and add additional data or config nodes is very low, and it doesn't happen very often. So for us, that's not a major issue. And we've maintained the Helm deployment to the state. So if we have a look here, we can see some of our Kubernetes workloads. So you can see that this is an example of one of our deployments. You can see that we're using stateful sets, so that all of our config nodes and data node pods have known DNS entry names when they're spun up. So we know we're going to get config node 0, 1, and 2, and data node 0, 1, 2, 3, and 4. And we know what those names are always going to be the same. The other thing you'll notice here is that we've got 2 deployments of IoTDB. We've got one which is just VROC.AI, and you can see there's a VROC.AI config node and a VROC.AI data node. But we've also got VROC.AI fast data node and VROC.AI fast config node. Now, as I said, the beauty about IoTDB is it's very, very lightweight, very, very performant with very low resource usage. And so what we can do is in this particular deployment, we've actually got a fast IoTDB deployment, which we use for front-end data. And we've just got a regular IoTDB deployment, which we use for AI analytics data. And that's because we don't want a large AI training load to slow down the database for the front end. We always want the front-end database to be fast, and we always want the front-end database to be very lightly loaded. The AI training databases can be really heavily loaded because they're not time sensitive. And so we maintain 2 identical copies of our database, one for front end and one for AI model training. And this is only possible because of the lightweight nature of the IoTDB deployment. So here you can see more of the Kubernetes workloads. I won't go through this, but basically this just shows you the pods, as I mentioned. We're using stateful sets, so our IoTDB config nodes will always be called VROC IoTDB config node 0, config node 1, config node 2. And so as long as IoTDB references and tries to communicate to the config nodes and data nodes by DNS name and not IP address, we're all fine. But occasionally we do have issues with it trying to use the IP address rather than the DNS name, and that can cause some problems. But in general, this solution works very well. For our IoTDB ingestion, so obviously we have quite a variable volume of data coming in. I mean, it can be stable, but it can go up and down as well. So we need to be able to handle those peaks and troughs. So we use Spark Streaming for that. We have a Spark Streaming process to handle ingestion, and that Spark Streaming process distributes the ingestion across all of the data nodes to spread the load. So we don't hit one data node specifically. We try to spread the data across the data nodes to improve the performance and reduce the load on the system. Spark Streaming also provides redundant ingestion processing. So in the event of a Spark Streaming pod failure or a hardware node failure, Spark streaming will resume and will ensure that we don't miss any data. It might ingest the same data twice, which is not a problem for us, but what would be a problem for us would be for us to miss data. And that goes to my next point, which is the fault tolerant ingestion processing. So Spark streaming will ensure that no data is lost, and it will continue to retry it until it's successful. Again, with our VROC IoTDB ingestion, we use a Helm script to facilitate rapid deployment. And as I mentioned, the Kubernetes cluster takes care of the automatic load balancing of containers and the redundancy if nodes fail. All right. So data retrieval for processing. So this is also important. So once we've got the data in, we need to get the data out. So for big data workloads, we use Spark. We use Spark processors, and that allows us to, again, distribute the processing across the data and distribute the data retrieval across the cluster as well. So we have multiple processes that run as part of our Spark processing, and they all hit multiple data nodes. So we're not pulling all the data from one data node, we're pulling the data from multiple data nodes at the same time, again, to reduce the load. Similar to some of the other things I've been saying, again, we get the redundant processing in the event of a hardware failure, and again, we ensure data is not lost when hardware fails. So things are retried when things go wrong. For the front end, so that was for the back end. So that's more for AI model training and other calculations that need to be performed. For the front end, we use Java native API to retrieve the data. We have a custom API that generates IoTDB queries and does some additional data aggregation and calculations, which might be difficult to do in IoTDB. We can do them as part of our data retrieval API. We have, again, some additional processing and aggregation as data is streamed to the front end. So we get some data from IoTDB. Some of it might be aggregated or calculated in IoTDB, and some of it may be calculated or aggregated as part of the streaming to the front end. And as I mentioned before, we have multiple IoTDB instances. So for the front end, we use the fast instance, and that's only used for the front end. For the model training, we have another instance which can be much slower. So IoTDB, the good and the bad. So what do we like about it? We love low resource utilization. We love the small number of different components. And obviously we love the high-speed data ingestion and data retrieval, all fantastic and pretty typical requirements for a time series database. The bad things, the things that we don't like so much, of course, there are some bad things. So some bugs and issues with corrupt segments. I think some of these are being fixed recently, but these were traditionally an issue for us. We historically have had issues with Kubernetes due to the dynamic IP address of the pods. So as I mentioned, in the stateful set, we have pods with consistent names. Each time the pod is restarted, or if one fails and it has to be restarted again, it comes up with the same name, but it doesn't come up with the same IP address. So although the DNS name is the same, the IP address is different. So if IoTDB doesn't try to re-resolve the DNS names, then we're going to have trouble talking to that node. This has been less of an issue of late, but that was an issue previously where when pods restarted due to a failure, IoTDB would never recognize them until the whole database was restarted. The other thing that we don't like so much at the moment, and I think this is also, most of these things are being fixed, which is great to see, but the data sync pipeline is not 100% reliable yet. We had lots of issues with data sync pipelines. As I mentioned, we run two identical sets of the database. We run a fast and a regular version, and we originally had data sync pipelines to synchronize the data within those databases, but we found that over time, those databases still became out of sync, and the data sync pipeline had a tendency to stop and fail at various points. And so now our Spark streaming job that pushes data into the IoTDB databases now pushes into both databases. Both the fast and the regular database get pushed at the same time from Spark streaming. And so if one of them fails, then Spark streaming doesn't continue until everything is consistent. So let's have a look at VROC application to various industries. So VROC for oil and gas. So again, oil and gas, very expensive process, a very expensive failure. If things stop running, it's a large cost. It can not only be a large cost in lost production, but it can be a large cost in getting parts and expertise out to offshore to repair the damage. So for oil and gas, again, we do analytics for the platforms itself. We do predictive maintenance or predictive analytics to identify when things are going to go wrong, what's going to go wrong, what parts they need to send offshore to ensure that they can keep the plant running. And we also do enterprise-wide analytics when they've got multiple assets that are all either producing into a common pipeline or producing it to various customers. We can identify where the issues are and where the team should spend most of their time to optimize the system as a whole. Process optimization as well. So oil water separation, sand production, moisture content and glycol separation, corrosion, energy consumption. These are all valuable insights that we can produce to optimize these offshore oil and gas facilities. Similarly with mining, I won't go through this too much, but it's very, very similar. Various types of mine sites, tailings and storage facilities, again, identifying predictive maintenance opportunities, fixing things before they break, ensure that the plant runs for as long as it can, extending asset life cycle, and improving shutdown and maintenance planning. Again, process optimization opportunities come from energy consumption and emissions reduction, as well as energy management reporting, so understanding what's going on. In maritime, it's very, very similar again. Shipping fleets, port and freight operations. Again, increased reliability of key assets. I mean, these are obviously expensive assets, and they need to be in operation as much as possible. We want to extend the life cycle of these assets, and we want to improve the maintenance, execution, and planning. Again, enterprise-wide performance monitoring is possible. If you have a fleet of ships or you've got a number of ports or lots of quayside container cranes, this can all be advantageous for you. And again, similar to the other industries, process optimization, improving loading and offloading times, better training for operators in the case of quayside container cranes, making sure they lift the containers in the right way to optimize the performance and reduce the strain on the machinery, as well as energy consumption and emissions reduction. Again, utilities, we do a lot of work in utilities, wastewater treatment plants, power stations, desalination plants, water treatment facilities. Again, it's a very similar sort of thing to the others, but they have the added benefit of chemical usage reduction by optimizing the chemical processes. And if we look at smart cities and facilities, again, very, very similar. Buildings, wastewater and water treatment plants, irrigation and water supply, street and decorative lighting, smart parking, waste management, sporting and aquatic facilities. They run a lot of very, very disparate assets. It's very hard for them to have expertise in all these areas. So having an AI analytics platform watching that all the time is of great benefit to them. And again, optimizing those for power, chemical usage, asset life extension, maintenance planning, very important in those industries. I'll skip a few of these over, but because I want to go through a few other things before we run out of time. So one thing we also do is enterprise-wide performance monitoring. So if you have a number of assets in a specific area or globally, as a management team, you want to be able to understand how all these assets are performing. You want to understand where we should be spending our time and money to ensure we get the best return on investment. So enterprise-wide performance monitoring is very important because rather than just looking at each facility in isolation, we can now use AI and analytics across all of those industries, across all of those assets to work out where the best use of our time and money actually is. Right, so let's look at a few case studies and a few customer success stories. So in utilities, we're doing a lot of work in PFAS, which is the forever chemicals that people are trying to get rid of at the moment. So we've got we've got a customer that has packaged plants for PFAS that can be deployed globally, off-the-shelf facilities, and so they run VROC Oasis to be able to monitor and control those facilities no matter where they are in the world. So as they deploy them, they just get added to their central operations center, and they can monitor all of the facilities globally from one central location. A huge cost saving for these guys. And then you're able to do analytics across all of these facilities to work out which ones are performing well, which ones aren't performing well, what maintenance is required. In smart cities, we're doing a lot of work for the city of Bunbury at the moment. So all of their assets are coming onto our platform, from decorative lighting to stormwater pump stations to sporting fields. Lots and lots of different things being added at the moment. And again, that platform is using IoTDB to store the IoT data, but it's using our Oasis front end to be able to allow them to monitor and control all of their assets across the council from one location, from their mobile phone or wherever they are. So in maritime, we do a lot of work with port operators. We do a lot of quayside container cranes, the cranes that pull the containers from the ships to shore and from shore to ship. And obviously those cranes, when the ship comes in to be loaded or unloaded, it's very time critical. They may be coming from a previous port and having to go to a next port. So being able to load and unload them in the time allocated is very important. And so ensuring that our quayside container cranes are serviceable, ensuring that any maintenance is performed between ships, and that all the parts that we need are available and ready to go is very important. And so we're able to provide assistance in that area to ensure that those assets are always in good operating status and are always reliable when required. And in mining, we do a lot of work in mining with mining operators. Obviously, mining is also an industry where there's a lot of large, heavy equipment that needs to remain in service. We've got things like underground ventilation fans, we've got haul trucks, we've got all sorts of different rotary kilns, we've got conveyors, we've got crushers, we've got screens, we've got lots of different equipment. And so being able to monitor all of that using predictive analytics, again, allows better maintenance planning, allows them to improve reliability and ensure that the plant remains running at all times. And so if we just sum this up again, IoTDB is a database that we use, but we use it because we need to provide these benefits to customers. We need a solution that can allow them to optimize what they're doing and run their plants better. And so when you see savings like 83% reduction in production losses, $24 million saved with one of our Southeast Asian operators, increasing reliability from 60% to 100%, improving flaring compliance from 50% to 100%. These are big deals for our end customers, not only for our customers, but, in the case of a lot of these improvements, there's also a significant environmental impact. So improving flaring compliance. So previously, they were only 50% compliant with their flaring. So they were paying $5 million of flaring fines a year because of the environmental damage they were doing. So we would much rather them not do any environmental damage by using this technology and be fully compliant with all of the regulations. So this technology does have the capability to provide significant customer benefits, significant societal and environmental benefits, and our partnership and our use of IoTDB is only allowing us to provide better and better solutions to improve our customers, provide them more timely insights, and really make the most of the data that they have. Thank you very much. I hope you enjoyed the session. Please feel free to reach out and contact me if you'd like any more information. We're only too happy to help to ensure that your project is successful and that you can successfully use this technology. Thank you.